So in this video, this is the second part of the lesson number 2. So in this video, what we're gonna do is to cover the topics that we left with from the previous class. So now, I remind you that in previous class we covered, the last thing that we covered was formula of slope, and I gave you the exercise related to parallel and perpendicular lines. Then after that, it follows quadratic functions. So hopefully by the end of the lesson, you'll be able to understand what are those quadratic functions, how to solve them, how they look like, and many more. On top of it, we'll also cover absolute value, system of equations, and I think that's about it, if I'm not mistaken. So without further ado, let's dive. In SAT, as far as you know, we have a topic, quadratic function, and we have a graph which looks like this. This, in other words, called parabola. So usually, in most cases, it looks in this way or in that way, like the curve is vice versa, like the curve looks upward, downward, that's it. But it's a rare case scenario when you see that it looks like in sideways. It doesn't look. It always goes up or down. That's the first thing that you're gonna know. Second thing is, if a is more than 0, then your parabola looks upwards, and a is less than 0, it looks downwards. Just remember these two things. I'll let you know what I mean by a and in the next slide. And the next thing that you have to know here is we have two things when we deal with parabola. We gotta find out, we gotta know that the maximum or minimum point, which you also must remember about it. And another thing is points of basically solutions of this parabola. Now in this case, we see that it is a minimum point. Why? Because every number that is above that number, it goes up, numbers go up, and they are higher than this number. This number lies at 0. And as you can see, it goes up till infinity. The more you go up, higher number you get. That's why we call this the lowest point. But if it were in this case, let me draw it. If it were in this case, then this is the highest point, because every number that goes below, you can see with minus, and they are less than this number. So another thing that you have to know about parabolas is these 3 cases, scenarios. So number 1, I want to get your attention here in this graph. So as you can see, I tried to draw myself this graph, and here you can see that there are 2 points of intersection. Why it is important, you may ask. In parabolas, in functions, points of intersection means how many values lie on x-axis. For example, let's say this one is 2 and this one is 4. Then our point of intersection, or aka our solutions for this equation, will be 2 and 4. In that case only, we don't care whether it crosses y value or doesn't cross. We care only about whether they cross this x-axis. This one is x, this one is y-axis. So this cross twice, which means we have 2 solutions. Only if it crosses x-axis twice, we will have 2 solutions, as it's written here. In second case scenario, if our parabola touches the x-axis only once, as you can see, here it is touched once, it also touches once, then our solution, let's say it's 3, must be only 1. That's it. We don't care whether it touches y-axis or doesn't touch. The important part is whether it touches x-axis. That's how it works, and you gotta know this. And the third case scenario, finally, is if it doesn't touch the x-axis, then in this case, we don't have any solution, because in other words, x means solution. They are equal. If you are asked about what are the solution of this parabola, you say 0 solution or 0 axis. This could be represented with this one, with discriminant. If it's more than 0, it equals to 2 solutions. If discriminant equals to 0, we've got 1 solution. If discriminant less than 0, we've got 0 solution. You gotta remember this. I'll explain what is the discriminant in the next slide. Now, here it is. Forms of functions. First of all, let me direct your attention towards this discriminant formula, which I talked. Now, you gotta know this. It is independent from this formula, but this is the quadratic formula, this is the discriminant formula. But to find out, based on this ideology that we talked here, whether our discriminant more than 0 or less than 0, we have to implement this formula. It's just a short way of this formula if you think about it, if you take this part. They look similar. So, what do I mean by this? Let's say we've got this example. Here it is. Before that example, I want to note one thing here is, we have 3 different formulas or forms for quadratic functions that you also must remember. It is have to do things, so it's better to open your laptop or, I don't know, notebook and write things every detail here, because we came to the important part. The first thing is, you can either look from here or from there, is the standard form. This is the form of it. This is the example for this. The standard form are given for us to see the y-intercept of the graph. We can see the y-intercept of the graph based on the standard form. That is, our c value equals to y. All the time remember that, in standard form. In this case, you can see that our y equals to -8. And this is why we need standard form. You're just gonna remember this. You're just gonna memorize it. Then we have the vertex form, which looks like this. And here it is the example. I wanna note that you gotta be very careful with the sign here. This is minus, this one is plus. Don't get confused, because in exam, you'll be tricked with a lot of similar questions and answers similar to this, where even a small sign can change your answer and make a big difference. That's why first one minus and plus. It's better to remember this. This is the quickest and easiest way to solve these equations. So why do we need this vertex form, you may want to ask? Obviously, we want to see vertex from it. Vertex, in other words, are the maximum or minimum point of the parabola. Here it is, it's written maximum. So based on this, our x is at 1, our y is at 9. Why it is, you may want to ask? Because, just remember in a simple way, in short way, there is a life hack for you. With x comes x, and the another variable without anything is y. Don't pay attention for now, because a defines whether your parabola goes upward or downward, as we talked in the previous slide. Here it is. If it's more than a, it's upward. If it's less than a, it's downward. That's how it is. So we need vertex form to see what? To see the vertex, to the maximum and minimum point. To see maximum and minimum. I remind you that maximum minimum point in parabola looks like this. This one is minimum. If it goes this one is maximum. For example. Now, just a moment. I'm gonna get this pen. Oops. I apologize for this. I just wanted to get that pen. Now, back to my point of finding discriminant, whether it's positive or negative. Let's get this example. Pay attention that we gotta work with standard form only, because in that way we can see our B, A, and C variables. Why we need this? Because in the formula it is with these variables. So in standard formula, this looks like this, and we get this example based on this standard formula. So you see the pattern, they look similar. However, you want to ask, where is the a here? We don't have a. If we don't have anything before x squared or before x value, it means that we all the time have 1. It's multiplied by 1. That means that our a equals to 1. We just want to write it for ourselves. A equals to 1. Then what we need based on this formula is b. We've got b, which is -2. Write it down. And c, our c is -8 based on this. Now what we're gonna do is put it here and multiply by 4 by squaring this 2. If we square 2, because it was our b, it will be 4 minus 4 multiplied by 1 is minus 4. Then minus 4 multiplied by minus 8, because of a c, we're going to multiply it by c, will be plus 32. Then if we add them up, we'll get what? 36. Which means that our discriminant is positive. And I remind you the scenario, if our discriminant is positive, which means more than 0, we've got 2 solutions. If it equals to 0, we've got 1 solution. If it's less than 0, we don't have any solution. This is the easiest way of finding how many solutions you have in your equation. Now you want to say, why do we need quadratic formula then when we have discriminant? Easiest way of solving it. Because in some cases, you'll be asked to implement this formula, and it's all the time better to memorize those formulas rather than not learning them, okay? You just remember them because they help you to find out your x-intercepts. We found out that we have 2 solutions, but we don't know what are those 2 solutions. If you implement this formula, you will see your 2 solutions. But it is actually an old-fashioned way of doing it. You've got Desmos to see 2 solutions exactly. However, as I said, there will be questions, which theoretical questions I call them, which merely ask you to work with this formula. I like you to show one example for this, with Desmos and with manually. So let me open Desmos. I'll be back quickly. Okay, here it is. Here is a Desmos. And now let me get one example to show it quickly here. Get this example. You just want to familiarize yourself with Desmos because it's a great tool for you under exam condition. It saves you a lot of time with most equations. See, there are 2 solutions, 2 x coordinates, which is minus 2, then 4. This is a parabola. Looks upward, sorry. We've got point. Vertex. Our vertex is 1 and minus 9. So the point is we've got 2 solutions, which means we could also calculate with this formula, with this discriminant formula. How you might want to ask, I'll show you in whiteboard. Just quickly here. We've got whiteboard. So let me quickly write it down. So to find out discriminant formula, discriminant basically from here, we gotta put into this formula. I know this formula, so let me put it. So this will be 2. Why in this way, you might want to ask? All what I did, just put in this formula and write it down. Remember, here we've got 1. Our A value is 1, our B value is minus 2, and our C value is minus 8. I put everything into this formula and try to find out the solution. Pay attention to the sign. Here it is minus. Then in the formula here, we've got also minus. 2 minus will give plus. It should be plus. If you don't have anything, it means already plus. So if you want to simplify this, we can have 2 solutions. One solution is, from this, it will be 36. From the roots 36, we will get 6. 2 plus minus 6 over 2. It will be 8 over 2, which means 4. One solution is 4. And our second solution is 2 minus 6 is minus 4 over 2, which means minus 2. Here it is. So the same thing we've got with the help of Desmos, minus 2 and 4. But it's the quickest way of doing it with the help of Desmos, obviously. But you gotta know, as I said, you'll be tricked with these kind of questions. That's about it. That's all what we have to know for now. Now, for the last thing is factored form. Why do we need factored form? We need it in order to see our x coordinates. Let me open this Desmos again for a short. Here it is. So we need a factored form in order to see our x coordinates. So in this case, if we were to write it in this factored form, we would write it as x not equals to, but plus 2 in squared, then x minus 4. This is how it looks like if you put it into factored form. From here, based on this formula, pay attention to sign again. They are in minus, so that's why it was in minus. With 2 minus, it will give plus. But if you take it as a solution here, we will take minus 2. It's actually minus 2, but it looks like plus. Just don't be confused with this part. And if it's in minus 4, it means it's 4. Because in the initial formula, it looks like this. It should be minus there. This is the rule. I know that may be confusing, especially for those who don't know about it, but try to digest it and try to do some exercise in order to get better in it. This is how we need it. This is why we need it. So I'm going to repeat myself. This is for x solutions. Factored formula is for x solutions. Vertex formula is for to see maximum and minimum point, and standard formula is to see only y-intercept. That's it. We have 3 formulas for 3 purposes. You gotta just remember them. I'm gonna show you with examples and explain more. But now let me explain you composite functions quickly here, because probably in the next video I'll show you examples. I'll dedicate one lesson to solve those complex examples. But for now, let's cover the topic, which is composite functions. In other words, functions inside of the function, as you can read from here. Golden rule here is to stick to the formula. Stick to the order and remember about what you are being asked. So it represents a two-step process where g of x is evaluated first and its result is then substituted into f of x. Let me show quickly what does it mean here in example. Here's an example. If f of x equals to x squared minus 3x minus 1 and g of x equals to 1 minus x, what is the value of f of g of minus 2? Since minus 2 g covers minus 2, we gotta put minus 2 instead of x. If you put minus 2, 2 minus will give plus, and if you add them up, we'll get what? It will be 3. The result of the g of x will put instead of f of x. Then we gotta put 3 instead of x. If we put so, it will be minus 9 minus 1. What we're left with minus 1. So our answer is minus 1. That's how we solve it. Just stick to the order and don't get confused. This is simple, although its name suggests that it's a complex composite function. It is actually simpler to solve it. And the next thing, as I mentioned, order matters significantly. So in this case, let's look at this. So it says we are given 2 set of numbers and we are asked what is the value of g of f of 2. So since f of 2 covers first, we have to look for the f of 2 there. And we have only one option with f of 2. Okay. Then remember that similar to this one, but we don't have any variable, any unknown number here. Similar to this number, we get one number and put in this number and it will be the result of this number, okay? Because we put minus 2 there and it resulted 3. And if you put 2 there, it will result 0. Cool. We've got 0. From what? From if you put f of 2 there. And remember that result will put in the another function to find the another result of it. If you put 0 into the another function, which is we have to look for 0 there, we've got only one option there. And what result will be 1? And our answer choice is C, 1. Don't get confused. You might want to replay it back and write it down on your notebook or laptop. Just be careful with this. That's it. Now, without taking too much time, I want to cover another topic straight away, which is system of linear equations. Here it is. In SAT, we have system of equations which we have to solve, and there are many ways of solving it. I'll show you in a moment every step, and the best way of solving it would be with the help of Desmos nowadays, especially if you are setting the test SAT, when you are given with this amazing tool Desmos. You just want to put these two equations into Desmos and see the point of interception, and that point is your solution. Or you can go with the method of elimination there. Method of elimination sounds like you gotta choose one variables with x or y, doesn't matter, it's up to you. Let's choose with x. Then you see you want to equalize these two in order to eliminate these two. So for example, when these two will be equal, if we multiply 2 here and if we multiply 5 there, because if you multiply it will be 10, it will be also 10. But by multiplying, we gotta multiply for everything with the method of FOIL. The same goes here. We gotta multiply every. If we multiply, it will be what? 10x plus 35y equals to 34 multiplied by 5. Here we've got also 10x plus, minus, this must be minus 8y equals to minus 2. This will cancel because they are similar. If their sign are equal, we have to subtract these two. if their sign, let's say it was in plus, it was in minus, if they're different, then we had to add them up. So since they are equal, we're just subtracting them, and we implement subtraction here as well. So if you subtract with 2 minus 35 minus 8, minus again 8, it will be what plus? It will be 43y equals to, now we gotta calculate 34 multiplied by 5 will be 170, sorry. And 170 subtracted by minus 2, and again minus 2, it will be 172. And we gotta, let me just write it down. So we gotta find y. If you wanna find y, we wanna divide 172 by 43. That will be 4. We've got 4 for our y value. And we can put this y value here or there in the initial equation. Let's put it here in simple term. And instead of 5, we'll put there, and it will be what? It will be 5x minus 16 equals to minus 1. 5x minus, if you subtract minus 16 from both sides, we'll be left with what? Minus, just a moment, plus 15, x equals to 3. This is our nice solution. This is how we find x and y, but I'll show you the easiest way, as I mentioned it, with the help of decimals. Instead of doing a bunch of these calculations, you go decimals and type these two equations and see the point of intersection. Let me show it briefly. And here you are. We've got 3 and 4. 3 for x, 4 for y. The same solution here. That's why I recommend you to just write this into the decimals and get the answer. Substitution also takes a long time, so that's why I don't recommend you to go with this method. Use decimals. Optimal way out of this is decimals. That's it. I don't want to take too much time with these two methods. That's about it. I'll show you examples in next videos in the future. But for now, let's look at absolute value. What is it, absolute value in SAT? Absolute value, also known as modulus, defines the non-negative distance of a real number from 0 on a number line regardless of its direction or sign. And the golden rule here is, out of absolute value, you can't get number with minus sign. It all the time has to go with plus. Why? I explain core logic here. Absolute value, in other words, means the distance between one thing to another. Let's say distance between A and B. So you see what? 4 meters or centimeters or kilometers, you name it. The important thing is 4. So it goes by 4 distance. Logically, if you think that distance cannot be with minus, as sides of a triangle or, I don't know, rectangular, square, side cannot be minus as well as distance. It only goes up, but not. Have you ever heard it goes minus 5 steps away? Nope, it's wrong. It goes 5 steps or 5 kilometers, 5 feet, doesn't matter. That's the core concept of the absolute value. And we've got 3 forms to remember. First one is f of x equals to a. Don't let these formulas, by the way, to scare you. They look scary, but in practice they are simpler. F of x, in other words, means y. It's just a tricky way of saying it. Equals to a. A is any number. F of x equals to g of x. And we have another, they are just a view of those formulas, but all of which require different steps and methods to solve. I'll show you in practice. You just remember these 3. So there's 2 ways of solving it, absolute value. One is manually, and the second one is decimals. I again recommend you with the help of decimals because it's fast and it guarantees you the quickest and safest answer. But by doing manually, you'll risk to make mistakes with simple calculations. But anyways, I'll show you manually as well. So as you can see here, when you are given this equation, which is in the form of a, see, f of x, we also have f of x in the form of a, that equals to a. This is our a. This is our f of x, let's say. Now, what we're gonna do is we have to solve it twice in order to find out our solution, because also in decimals you'll see 2 solutions. One way of solving it would be just ignoring these brackets and solving it and finding x from there. If we do so, you'll find there. You gotta be familiar with linear equations. And another way of solving it with the minus sign. You put all the time minus before this a value, and you find another solution which is -1. And this is our solutions for this equation. If you do this with the help of decimals, you'll get the same response. Let me show you an example with this second formula. Let me open my Blackboard. Now let me show you this briefly, these two examples here. First one is for the formula of f of x equals to g of x. So the easiest way of solving it, first method is to just ignore these brackets. You just ignore it and write it down without brackets. You find x from there. If you want to find x from there, you subtract x from both sides, and you add 1 to both sides. You'll be left with -5. This is our solution. You just ignore this. This is for this f of x equals to g of x. In this way, though, you can't do this. It requires you a little bit of different methods. So you just want to remember one golden rule. Think to yourself, like, what makes this number inside of the bracket equal to 0? For this case, it is -2, obviously. How about with this one? It is 1. If you put 1 there, it will be 0. Now we have 2 points. And we want to write it down again without these brackets, but with ordinary brackets, like in this way. Just change it, or it doesn't change. It's the method of solving. It's up to you. Then what we have to do here is to find out x from there. To find out x, because they are ordinary brackets, we just open them and solve them. This will be x plus 2, and if you open them, minus fx, this minus, it will be plus, minus x plus 1. So this one is plus, this one is 1, this one is 1. So from here, we gotta find x. This cancel, this will also cancel. Now here we see that everything is subtracted, and we have 2 equals to 0, which means it doesn't equal. So you may have the solution here, but in this case, there is no solution. Let's have a solution. Actually, I don't encounter this kind of question in SAT, but it's better to know it rather than not know this. And the last thing, hopefully, that we have to cover for today is inequalities. So there are some terms that you gotta know when dealing with inequalities. First thing is the term more than. If it says more than, it is obviously more. If it says less than, it is less. It is more than or equal to, it means at least more or at least equal to this. If it says less than or equal to, it is either less than it or equal to this. So as we covered in first class. Now I'll explain you solving this system of inequalities with the help of decimals here. So you see these lines, these colors, and if you type them into decimals, you'll get this graph. If you type this equation, let's say, in decimals, you'll get this graph. And anything that lies in colored region are your solution, is your solution. Anything is beyond this region is not your solution. The same goes with this one and this one. With 2 points of intersection, two equations, like a system equation, you want to see where these 2 colors intercept. In this case, they intercept in this point, where the solution is. Now, the easiest way of solving it would be with the help of decimals again. I don't recommend solving it manually, but if you want to solve it manually, you can watch these 2 videos designed for you to teach how to solve them. But I would show you to solve them with the help of decimals, where you can just type these things and find out where the color basically cross, where the graph of the color shows. As you can see here, I typed equation to decimals, the first example, and you see that region is colored with this one except this region. And the starting point is 3 at 3, as you can see there, and at 9, which means that our solution starts from 3 and goes to the minus infinity, and then it goes from 9 to the infinity itself. These numbers aren't the solution. That's how we solve with the help of decimals. There's no need to solve it manually. And of course, you can do the same thing with other examples. That's about it. I hope that lesson was informative for you and you've got something useful. If you didn't, please, I recommend you to watch this video again and understand things in depth. I attached those videos, and it will be also useful for you to watch these videos as well. Thanks for watching. That's about it. These are the all topics that we covered so far, and I hope that after some time and some hours of practice, you'll be able to ace this type of questions. That's about it. Take care.